Okay, I want you to imagine something for a second. What if your database wasn't just a bucket for data? What if it was alive? A system that actually learns and gets smarter every single time you use it. Well, that's not science fiction. That's the whole idea behind a new project called RuVector. And believe me, it could completely change how we think about data.
I mean, really think about it. Most of the databases we use today, they're kind of just static boxes, right? You dump data in, you pull the same exact data out. If you want better search results, well, that's on you. You have to go in and manually tweak and retune everything. But what if that wasn't the case? What if your database could actually learn from every single query you make, getting smarter and smarter all on its own?
And that's exactly what RuVector is all about. We're talking about a system that's self-learning and self-optimizing. It literally watches how you interact with it and adapts on the fly.
So, let's break that down a bit. This slide really puts it in black and white. On one hand, you've got your standard vector database. The search quality, pretty much static. You want to improve it, you got to get your hands dirty and tune it yourself. But then you have RuVector. It uses something called a graph neural network. Think of it as a little AI brain that understands relationships. And this thing learns from every single query, so your results just get better and better over time. And that tuning part? It has this thing called the Sona architecture that automatically tunes the system for your specific workload. So the big takeaway here is, it's not just storing data anymore, it's actively building intelligence.
So you might be thinking, okay, this sounds big. What is it, really? Well, the best way to wrap your head around RuVector is with an analogy the creators themselves use. Don't think of it as just one tool. Think of it as an entire tech stack of things you probably already know, all mashed together into one super fast package.
So, at its very foundation, yeah, it's a vector database, kind of like Pinecone. It takes your data, turns it into these numerical representations called embeddings, and then lets you do crazy fast similarity searches. That's the base layer.
But then it stacks something else on top. It's got a full-blown graph engine, just like you'd find in Neo4j. And this is a game changer. It means it doesn't just see a bunch of isolated data points, it actually understands the deep, complex connections between all of them.
And we're not done. On top of that, it has a built-in runtime for large language models, kind of like llama.cpp. This means you can run your AI models right on your own machine. No more calling cloud APIs, no more paying per token. The AI lives right there with the data.
And to top it all off, it handles the whole deployment and packaging thing just like Docker. It lets you wrap up everything, your data, your models, that graph, into one single executable file that can literally run anywhere.
So yeah, when you put all those pieces together, what you're left with isn't just a database. It's what they call a complete cognitive infrastructure. You've got vector search, graph smarts, local AI, and easy deployment, all compiled down into a single, highly optimized package written in Rust.
Okay, so the big question is, how does it actually do the learning part? Well, the secret sauce is that graph neural network we mentioned earlier. It basically acts like a brain that sits right on top of all your data. Here's how that learning loop works, and it's pretty slick. When you make a query, the GNN looks at your query and its closest neighbors, and the data. Simple enough. Then it uses this thing called an attention mechanism, a fancy way of saying it figures out which of those neighbors are actually important for what you're asking. Based on that, it updates the data's representations to be a little smarter next time. And boom, it hands you back better, more relevant results. The more you use it, the stronger those connections get, making your most common queries faster and way more accurate.
And here's the kicker. It does all of that complex learning stuff while being absolutely ridiculously fast. Look at this number, 61 microseconds. That's the median search latency. Not milliseconds, people, microseconds. I mean, we are talking about performance so fast, it's hard to even comprehend. This is fast enough for the most demanding real-time applications you can possibly dream up.
All right, now we get to what might be the craziest, most game-changing part of this whole thing. Let's talk about how all this technology gets packaged up. It's called an RVF, or RuVector format file. And the creators are super clear on this point. This is not just another database format. They call it an executable knowledge unit. I love that phrase. It's not just data. It's a self-contained, intelligent package that can literally think and act all by itself.
And just check out what one of these little files can do. You can take an RVF file, drop it onto a virtual machine, and it boots up as a complete microservice in 125 milliseconds. Why? Because it has its own Linux kernel packed inside. That same file can also run queries directly in your web browser with a tiny 5.5 kilobyte WebAssembly runtime.
And maybe most importantly, every single thing that happens is recorded in a tamper-proof cryptographic audit trail. This is a totally new way of thinking about deploying intelligent systems.
So, okay, that's a lot of cool tech, but why does any of this matter? What can you actually do with this kind of thing in the real world?
Well, the use cases are pretty wild and incredibly diverse. People are already using it to orchestrate complex AI agent systems, basically helping different AIs work together. It's being used for instant genomic diagnostics, right on a phone, analyzing DNA in a flash. And of course, it's perfect for real-time edge computing, bringing some serious AI power to tiny IoT devices and sensors out in the field.
So we've seen how RuVector is this huge leap, right? We're moving away from databases that just store stuff to databases that can actually understand and learn. So I'll leave you with this final thought. If the very foundation of your software, the database itself, is intelligent, what does that mean for the future of everything we build?